Okay, so in this chapter for statistics 1, we're going to be looking at discrete random variables. So the idea is, which game would you rather play? We've got two games here. We have game A, which costs £10 to play the game, as it says. You have a 5% chance of winning £50, and a 30% chance of winning £25, and a 25% chance of winning £10. Otherwise, you don't win anything. Game B, the game costs £10 to play the game, and you have a 1% chance of winning £1,000 and a 5% chance of winning £50, otherwise you don't win anything. Which is the better game here? Well, if it costs £10 to play the game, then actually you're only getting 40 back there, aren't you? In this case, you're only getting 15 back, and literally all we have to do is do these to work out what per game it would be. So it's going to be 0.05 times by 40 plus 0.3, so 30% chance, multiplied by 15, and then a 0.25%, but you don't win anything, don't you, on that occasion. But you can potentially get a negative 10 loss out of all those options. Alright, so work that out there, you get, what was it, 2.5, £2.50. But that is per game. Alright, for option B, we have only 0.01% chance of 1,000 minus 10, which is 990, plus 0.05 times by 40, 50 minus 10, plus 0.94, which is 1 minus everything else, times by minus £10, which is also going to give you £2.50 per game. So, as a matter of fact, they are equal. So, to be fair, there's not much effect here. As a bit of a recap for what a discrete random variable is, a random variable represents a single experiment or a trial. It consists of outcomes with a probability for each. And for each discrete random variable, the outcomes are discrete. The probability that x is the probability that the outcome of the random variable x is the specific outcome of some x. The p of 5 would be the shorthand for probability of x equals 5, noting that it should be a lowercase p there. This chapter concerns how we can find special properties of a discrete random variable, so as its expected value, which is quite important, and its variance. The variance, of course, we know from the standard deviation stuff from what you've done in the past. Okay, so let's look at these games again. So, what we were looking at were chances, weren't we? So we were looking at if, say, we had a minus £10 loss, then as a matter of fact, the probability will be 0.4. What we're eventually going to do is multiply each of these branches, aren't we, in effect. If we had £0 when x is 0, well, that's just going to be a quarter. If we had 15, then that's going to be 0.3. And if we had 40, well, that's just 0.05. That's just converting it into a table, stuff you've done before. Now, what we know as the expected variable would be e of x, the expected value, which is quite literally the sum of x times the probability of x equals x. So, let's do that. Minus 10 times 0.4, you're going to get the drift here now. 0.25, 15, 0.3, 40 times 0.05, which is 2.5, exactly as we did before. Now, if we're going to do it for y, what we're going to get here, we're going to get minus 10, we're going to get 40, and we're going to have the 990 from this bit here, aren't we? So the probability that y will give you y for its outcome is going to be 1 minus 5 and 1, which is 94 as a percentage. It'd be 0.94, wouldn't it? And of course these are your 0.05 and your 0.01. Okay, so all we need to do is work out the expected value. Now the expected value of y is going to be minus 10 times by 0.94 and 40 times by 0.05 and 990 multiplied by 0.01. And that, fully enough, gives you 2.5, which is what we had coincidentally when we did it first time around. Interesting. That's very intriguing. So, yeah, if x is the random variable, e of x is known as the expected value of x, where we've got the sum of x times p of x. Fine. And it represents a mean outcome that you'd expect if you do it just constantly. Okay, so find the expected value for them. You could probably do these in your head, but I'm going to write these out. So we've got 0.1 plus 1.2 and 0.9. And you're going to get 2.2. For this one on the right here, that one you can very much do in your head is 2 and 1.5 and 2, which is of course going to give you 5.5. Cool. Suppose you treated the probabilities of frequencies and you found the mean of the frequency table. What would you expect? Well, means of a frequency table, we have x, f, and f times x, don't we? So we got 1, 2, 3, yada yada yada, 0.1, 0.6, 0.3, which does add up to 1. Then you get your 0.1, your 1.2, your 0.9, which is going to give you 2.2. And 2.2 over 1 gives you 2.2. So you're actually going to get the same exact thing as you did over here. So, if we look at this Z1 again now, again in your head, yeah, it's going to be what, 2.5 and 10 and 7.5, which of course 20. And if the distribution is indeed symmetrical, so both the outcomes and probabilities are symmetrical about the centre, then the expected value is just going to be that central value, as it is here, because these are symmetrical. However, we have to know how to do it with unknowns, and if you have two unknowns, you're going to have two equations, which means it's going to be simultaneous equations, probably. Now, we know that from our A-level maths knowledge that the sum of p will be equal to 1. So what we're going to do is multiply these together, aren't we? Just as we did previously. Let's do that. So, if e of x is going to be 3, find p and q, so we've got 0.1 plus p plus 0.3 plus q plus 0.2 is going to be equal to 1. That's just one equation. Let's just sort that out. So it's going to be p plus q is going to be 0.4. i.e. q is going to be 0.4 minus p. It's probably better writing it that way around. And then using the fact that it's going to be equal to 3, all we need to do is do 0.1, 2p, 0.9 plus 4q plus 1 equals 3. So we've got 2p plus 4q is going to be equal to 1. Very useful. So we got two equations that we can just solve simultaneously. Now, the best way to do this would be to just solve them straight. So it'll be 4 lots of the q, which we had was 0.4 minus p. And that's going to be equal to 1. Let's just quickly solve that there. That's going to be what? 0.6 is 2p. So p is going to be 0.3, which coincidentally means that q is 0.4 minus p. So which is q is going to be 0.1. Okay? Very, very straightforward, but it just gets you used to this method. So here's one from the old specification. Again, I'll let you pause, have a go, and I'll go through it. So again, all we do, we multiply across these branches as we did before. I'm going to write the x's just so I can show you the method. We're told that E of x is 4.2. We want to find what a and b are. That's fairly straightforward. It's 3a and 2b, giving you 0.7. Now let's do the algebra. So we've got a plus 2a plus 3a and 4b, 5b, and 1.8. Wow, this is some algebra, right? Let's try and solve this standard equation then. That's going to be, what, 6a and 9b. It's going to be 2.4. Now, of course, you can do these by elimination if you wanted to. However, if you've got your calculator on you and you put them in your simultaneous equation solver, you get 0.1 and a 0.2. You can go through the algebra. All you got to do is the 3 plus 2b, you're going to double that here, and then just subtract one from the other. And funnily enough, you get 5b will be equal to 1, so b will be 0.2. And you can kind of see where it's going to go from there. Okay, so that will be how you do that question. So, now we've got e of x, now we can find what e of x squared are, and e of 2x are, etc. So, for e of x only, if x is just a random variable, then the e of x is going to be 0.1 plus 0.8 plus 1.5, which is going to be 2.4. Hopefully you can see that. So 2x will just be double of these. It'll be 2, 4, and 6. And then the p of 2x will remain the same. Those don't change. i.e. e of 2x will just be 0.2 plus 1.6 plus 3, which is 4.8. And similarly, you'll be able to find what x squared is, so we just square these as the square numbers, 1, 4, and 9, and we still get the same probability, 0.4, 0.5. Okay, so what we find is this is going to be 0.1 plus 1.6 plus 4.5, and if we do a quick check on that, we get 6.2. i.e., what this means is we have the e of x squared is definitely not e of x squared. That's quite useful because people get those mucked around quite a lot. Okay, so let's find e of x squared together. So, you can do these straight in your head, but I'm going to show my workings as you was for 4, 0, and 1. i.e. then we can then find what e of x squared is, which is 4 times 0.3 plus 1 times by 0.1, which is 1.2, and 0.1, which is 1.3 there. Okay. Right. So at that point there, you can have a go exercise 1A in the Edexcel book, and it's just giving that practice all the time.